All right, let's talk about one of the most powerful concepts in programming, and that is making the computer do all the repetitive, boring work for you. Today, we are diving deep into Python loops.
I mean, we've all been there, right? You're just starting out and you realize you have to do the exact same thing 5, 10, maybe even 100 times. It feels clunky, it's so tedious, and you're just sitting there thinking, man, there has to be a better way. So, okay, if you want to print hello 5 times, sure, you could just copy and paste the print statement. But what if you needed to do it 5,000 times? Yeah, that's not just boring anymore, that is incredibly inefficient. And that is the exact problem that loops were invented to solve.
Okay, so our first tool in this automation toolbox is the while loop. And really, the name gives you a huge clue about how it works. It's going to repeat a block of code, you guessed it, while a certain condition stays true.
The concept here is actually super simple. The while loop is like a little gatekeeper. It just asks one question. Is this condition true? If the answer is yes, it runs the code inside. Then it goes right back to the top and asks again. And it'll keep doing this over and over and over until that condition finally becomes false.
Okay, let's break this down piece by piece. First, step 1, we initialize a variable. We'll call it count, and we set it to 1. Easy enough. Then the loop starts its check. Hey, is count less than or equal to 5? Well, right now it's 1, so yes. So it runs the code inside and prints the number 1. And now, this brings us to the most critical step of all. We have to update the variable. We add 1 to count, so now count is 2, and the whole process starts all over again.
Now, I cannot stress this enough. That update step is absolutely crucial. Seriously. Because if you forget that count equals count plus 1 line, what happens? Well, think about it. Count starts at 1. The loop asks, is 1 less than or equal to 5? Yep, so it prints 1. Then it goes back to the top. Is 1 less than or equal to 5? Yep, and it prints 1. It will do that forever. You've just created an infinite loop because the condition can never become false.
Okay, but what if you know right from the very beginning exactly how many times you need to repeat something? For that, we have our second major tool, the for loop. This is your absolute go-to for when you have a definite, counted number of repetitions.
So a for loop is designed to work its way through a sequence of items, just one by one. And for beginners, the most common sequence you're going to use is just a series of numbers that we can create with this super handy function called range.
So check this out. Range is really flexible. If you just say range 5, it gives you the numbers from 0 up to, but, and this is key, not including 5. So you get 0, 1, 2, 3, 4. Now, if you give it a start and a stop, like range 1, 6, it'll start at 1 and stop right before 6. You can even add a step to, jump over numbers, or, as we're about to see, use a negative step to count backwards.
So let's try it. If we use range 5, 0, -1, the for loop will grab the very first item in that sequence, 5. Then it automatically moves to the next item in the sequence, which is 4. And then, of course, comes 3,
Followed by 2.
and finally 1. Now the loop is finished, because remember that rule? It stops before reaching the end value, which in this case was 0. And just like that, once the loop has gone through every single item in a sequence, it's done. The program just continues on to whatever code comes next. All right, section 3, powerful loop patterns. Think of these as your first programming power-ups. Now that you've got the basics down, let's look at 2 super common patterns that will make your loops way more useful, the accumulator and the counter.
First up, we have the accumulator pattern. This is perfect anytime you need to calculate a running total. The idea is really simple. You just create a variable to hold your total, kind of like a piggy bank, before the loop even starts.
Here's exactly how it works. Let's imagine a loop that's running from 1 to 5. We start our total variable at 0. On the first pass, we add 1, so our total is now 1. Next pass, we add 2. Total becomes 3. Then we add 3, making it 6. Then we add 4, making it 10. And finally, on the last pass, we add 5, giving us that final sum of 15. See? It just accumulates the value. The counter pattern is super similar, but with a twist. Instead of summing up the values, we're just counting how many times a specific thing happens. It's like making a tally mark. You start a counter at 0, then, inside your loop, you check for some condition, like, hey, is this number even? And if it is, you just add 1 to your counter. It's a simple idea, but you'll use it all the time. Okay, so now you've got these 2 powerful tools in your arsenal. This leads to the big question.
the one everyone asks. When should you use a for loop, and when is it better to use a while loop?
Here's the rule of thumb, the most important takeaway. Think of a for loop like a train on a fixed track. You use it when you know the exact start and end point. You know exactly how many stops it's going to make, like going through a range of numbers. A while loop, on the other hand, is for when the number of repetitions is a mystery. You don't know when it's going to end, you just want it to keep going until some condition finally changes, like waiting for a user to type quit.
And really, that is the fundamental power of loops. They are the engine of automation in programming. They let you take all that tedious, repetitive work and hand it over to the one thing that never, ever gets bored, the computer. So now that you have this new power, the only real question left is, what are you going to build first?